March 16, 2026. In the last 12 hours, something happened that every major scientific timing system on Earth first dismissed as catastrophic equipment failure. But the more the data was examined, the clearer it became that the instruments were not broken. They were reporting the same impossible truth. Atomic clocks synchronized with the United States Naval Observatory, the National Physical Laboratory in London, and the International Earth Rotation and Reference System Service in Paris all detected a massive deviation in Earth's rotational period. Three independent institutions, using completely different measurement methods, reported the exact same reading. NASA's orbital dynamics analysts confirmed it. The Swarm satellite constellation verified it from space. Parkes Observatory in Australia checked the positions of distant quasars and reached the same conclusion. Every precise instrument capable of measuring time and rotation is now recording the same result, and the probability that this event occurred naturally is effectively zero. Earth's rotation has accelerated. The length of a full day has changed from 24 hours to 20 hours, and the data points toward a single correlated source, the object known as 3IATLAS. To understand why this change is not a measurement mistake, but a planetary emergency, unlike anything in the geological record, we need to start with one of the most fundamental principles in physics, angular momentum. Angular momentum is the rotational equivalent of linear momentum. For any spinning object, it is determined by two factors: the moment of inertia, which describes how mass is distributed, and the angular velocity, which describes how fast the object rotates. In a closed system, angular momentum is conserved absolutely. It does not simply change on its own. The only way to alter it is through an external torque. This principle is not theoretical speculation. It is a direct consequence of Newton's laws and has been verified in every rotating system ever observed, from subatomic particles to entire galaxies. You can see a simple demonstration of this principle when a figure skater pulls their arms inward and spins faster. By reducing the distance of their mass from the axis of rotation, they conserve angular momentum while increasing their spin rate, but Earth cannot do that. For our planet to accelerate from a 24-hour day to a 20-hour day through internal redistribution, the crust would need to collapse hundreds of kilometers toward the core. No such collapse has occurred. Earth's diameter has not changed by a measurable amount. That leaves only one possibility. Something external applied torque to a 6 sextillion-ton planet and shortened its rotation period by 4 hours in just 72 hours. The energy required for this transformation can be calculated directly. Earth's moment of inertia is approximately 8 times 10 to the 37th kilogram meters squared. The change in angular velocity between a 24-hour rotation and a 20-hour rotation is roughly 8.7 times 10 to the negative 6 radians per second. When physicists calculate the rotational kinetic energy difference between those two states, the result is staggering. The energy required is on the order of 10 to the 29th joules. For comparison, the total energy produced by the Sun every second is about 3.8 times 10 to the 26 joules. That means the rotational energy injected into Earth over the last 72 hours exceeds the Sun's output per second by hundreds of times. And yet, despite this massive energy transfer, Earth's surface temperature has not increased by even a fraction of a degree. This single observation breaks one of the most reliable principles in all of physics. Every energy transfer produces waste heat. The second law of thermodynamics is not a guideline, it is one of the most consistently verified laws of nature. Car engines produce heat. Nuclear reactors produce heat. Even exploding stars release enormous thermal energy. But somehow, 10 to the 29th joules of rotational energy have been added to Earth without leaving a detectable thermal signature. And that means the mechanism behind this acceleration is not operating through ordinary physical processes. The only explanation left is that the energy transfer bypassed the processes that normally create heat. In other words, whatever accelerated Earth's rotation did not push the planet the way gravity or physical force normally would. Instead, the data suggests something far stranger, a mechanism that couples directly to the gravitational field itself. The timeline of the event begins with a signal that initially looked unrelated. On March 11th at exactly 14 UTC, the International Earth Rotation Service in Paris detected the first anomaly. The change was not small. Earth's rotation suddenly deviated by 12 minutes. For scientists who normally measure changes in milliseconds, a 12-minute shift was so extreme that the instruments were immediately assumed to be malfunctioning. NASA's Goddard Space Flight Center recalibrated its very long baseline interferometry systems and repeated the measurement. The result was identical. At the same time, the Swarm satellite constellation operated by the European Space Agency measured a subtle wobble in Earth's rotational axis. That wobble matched the profile expected when a rotating body experiences sudden external torque. Meanwhile, Parkes Observatory in Australia performed an entirely different verification method. Astronomers there compared the positions of distant quasars objects so far away that they appear fixed relative to Earth's rotation with their catalog coordinates. When those positions were recalculated, the observatory reached the same conclusion: Earth's rotational speed had changed. Within 24 hours, the day shortened to 23 hours. By March 13th, it had fallen to 21 hours and 30 minutes. On the morning of March 14th, the value stabilized temporarily at 20 hours. But another measurement had occurred at the exact moment the first 12-minute deviation appeared. The gravitational wave observatories of LIGO recorded a coherent, non-dispersing gravitational signal directed at Earth's rotational axis. The coordinates of the signal pointed directly to the object known as 3IATLAS. When scientists compared the arrival time of that gravitational pulse with the moment Earth's rotation began accelerating, the correlation coefficient was calculated at 0.999. In statistical terms, that number no longer describes coincidence, it describes a direct mechanism. 3IATLAS was not simply nearby when the anomaly occurred, it was responsible for it. What makes the situation even more remarkable is the way the atmosphere responded. When a solid surface begins rotating faster, the air above it should lag behind due to inertia. That lag would normally create supersonic winds around the equator as the atmosphere struggled to catch up with the spinning planet. No such winds exist. Weather stations across the world report normal conditions. The entire atmospheric column from the ground to the upper stratosphere is accelerating together with the planet itself. Instead of behaving like a separate fluid system, the atmosphere appears locked to the rotation of the solid Earth. The data suggests that the torque applied to the planet is not acting only on the crust or the mantle. It is acting on the entire Earth system simultaneously, as if every component of the planet exists inside a single unified reference frame. In simple terms, 3IATLAS is not gripping the rock of the planet. It appears to be gripping the physical space surrounding it. Once scientists understood that the torque was being applied to the entire Earth system, the next question became how that torque was being controlled. The rotational acceleration curve offered an important clue. Instead of fluctuating randomly, the curve follows a smooth mathematical progression. The increase in rotational speed is not chaotic. It follows a logarithmic pattern, precise and predictable, suggesting that the process is moving toward a specific target velocity. Astrophysicists began running simulations using the observed acceleration curve. When the data was projected forward, the model produced a striking prediction. Within 48 hours, Earth's rotation could reach an 18-hour day. That threshold carries serious consequences. Modern satellites are designed around Earth's current rotation rate. Geostationary orbit exists at a very specific altitude where a satellite can remain fixed over a single point on the surface while the planet spins beneath it. If the rotational period changes too much, that altitude no longer works. At a 16-hour day, geostationary orbit becomes physically incompatible with the planet's rotation. Satellites that once hovered above the same position would begin drifting across the sky. Communications systems, weather monitoring platforms, and much of the global positioning infrastructure would lose synchronization. But satellite drift is only a secondary effect. The deeper consequence comes from centrifugal force. As Earth spins faster, the outward force at the equator increases. This reduces the effective strength of gravity in those regions. Even a small reduction has dramatic effects on ocean distribution. Water naturally moves toward areas where gravitational potential is lower. As the equatorial region experiences stronger outward force, ocean water begins migrating toward the equatorial bulge. The process does not create new water. Instead, it redistributes existing ocean mass. Coastal regions at higher latitudes would slowly lose water, while equatorial regions would experience rising sea levels driven purely by rotational mechanics. In other words, coastlines around the world could change not because of climate, but because the planet itself is spinning faster. When astronomers measured the rotation of 3IATLAS itself, they discovered something even more revealing. The object completes one full rotation every 20 hours. Earth's new rotational period is moving toward the exact same value. This alignment cannot be accidental. In physics, when two rotating bodies interact gravitationally and gradually match their rotational periods, the process is called tidal locking. The moon is tidally locked to Earth, always showing the same face because gravity synchronized its rotation long ago. But that process normally takes billions of years. What is happening to Earth is the same principle operating on a completely different timescale, compressed from geological history into just 72 hours. If the rotational change alone were the only effect, scientists might still attempt to classify it as an extreme but natural gravitational interaction. However, additional measurements show that something far more complex is happening. The northern hemisphere of Earth is now rotating slightly faster than the southern hemisphere. For a rigid sphere, this should be impossible. Every point on a solid rotating body must move with the same angular velocity. Yet the data indicates a small but measurable difference between the two hemispheres. This means Earth's crust is not responding as a single rigid structure. Instead, it is twisting. The torque applied by 3IATLAS is interacting differently with the massive lithospheric plates that make up the planet's outer shell. Under normal conditions, differential stress like this would trigger massive earthquakes across the world's major tectonic boundaries. Regions such as the Pacific Ring of Fire, the Mid-Atlantic Ridge, and the Himalayan collision zone would be expected to rupture as the crust struggled to redistribute the accumulated energy. But none of those catastrophic events have occurred. Seismographic networks show no unusual earthquake activity beyond normal background levels. This indicates that the same external field accelerating the planet is also stabilizing it. While one component of the field applies rotational torque, another component appears to apply compressive force across tectonic boundaries, preventing them from slipping. In effect, the planet is being spun and stabilized simultaneously. The scale of coordination required for such a process suggests that the force involved is not random gravitational influence. Instead, it behaves more like a controlled engineering system, adjusting multiple variables in real time. Earth's magnetic field has also begun responding to the acceleration. The geodynamo, the mechanism that generates the magnetic field through the motion of liquid iron in the outer core, is strongly affected by rotation rate. As the planet spins faster, the Coriolis effect becomes stronger. This effect organizes the convection currents in the molten outer core into spiraling columns that sustain the large-scale magnetic field. Within 6 hours of the rotational acceleration beginning, NASA's magnetospheric monitoring satellites detected a 12% increase in magnetic field strength. The measurement matches theoretical predictions almost exactly, and that stronger magnetic field is already beginning to affect human technology. Electrical infrastructure around the world depends on the principles of electromagnetic induction. According to Faraday's law, any change in a magnetic field can induce voltage in nearby conductors. When Earth's magnetic field changes rapidly, every long metal structure on the planet becomes part of an enormous electrical circuit. Submarine communication cables that stretch across entire oceans begin accumulating induced voltage. High-voltage transmission lines experience unexpected currents. Even long pipelines develop electrochemical potentials that accelerate corrosion. Engineers are already detecting unusual electrical behavior in power grids across several continents. These phantom currents are not the result of equipment failure. They are a direct consequence of the changing magnetic environment surrounding the planet. The electrical disturbances will continue until the magnetic field stabilizes. And the magnetic field will not stabilize until Earth's rotation stabilizes. But the rotation is still being altered. At 11:42 UTC on March 14th, the Gaia spacecraft detected another anomaly, one that transformed the entire situation from a rotational adjustment into a full planetary reconfiguration. Earth's axis shifted. For thousands of years, the planet's rotational axis has maintained an average tilt of about 23.5 degrees relative to the plane of its orbit around the Sunday. That tilt slowly varies over long cycles, lasting tens of thousands of years. Yet Gaia recorded a change of 0.08 degrees in just 6 hours. Even more extraordinary was the direction of that shift. When astronomers traced the vector of the new orientation, it pointed toward a very specific object in the night sky, Cygnus X1. Cygnus X1 is one of the most famous black hole systems ever discovered. Located roughly 6,000 light-years away, it consists of a stellar mass black hole orbiting a massive blue supergiant star. For Earth's axis to suddenly shift toward the coordinates of a known astrophysical object with such precision defies every existing model of planetary motion. Changing the orientation of a spinning planet requires a different type of torque than the one that alters rotation speed. It must act perpendicular to the planet's existing angular momentum, producing a gyroscopic effect known as precession. The data now shows that two separate force components are acting on Earth simultaneously. One accelerates the planet's rotation, the other slowly redirects the axis of that rotation toward a precise celestial coordinate. Despite the enormous forces involved, the stabilizing field surrounding Earth continues to prevent catastrophic geological consequences. The planet remains structurally intact, even as its rotational parameters are altered. If the acceleration continues toward an 18-hour or 16-hour day, centrifugal forces will begin redistributing the oceans toward the equator on a massive scale. Entire coastlines would shift as water migrates toward the region of maximum outward force. Yet the acceleration curve suggests that the target may not be 16 hours at all. It may already have been reached. 3IATLAS rotates once every 20 hours. Earth's rotation has now matched that period. When two rotating bodies achieve identical periods through gravitational interaction, the system enters a stable configuration known as synchronization lock. At that point, the torque that once accelerated the slower body begins maintaining the match state. The Moon is locked to Earth, Pluto and its moon Charon are mutually locked. 3IATLAS appears to have forced that process to occur between itself and Earth in only 72 hours. In advanced theoretical physics frameworks, particularly those exploring higher dimensional models of spacetime, gravity can be described as the curvature of a deeper structure underlying the universe itself. A civilization capable of manipulating that structure would not need to push a planet physically. Instead, it could adjust the parameters governing how mass interacts with gravity, effectively rewriting the local rules of motion until the desired configuration becomes the natural equilibrium. If such technology exists, the absence of heat, earthquakes, and atmospheric disruption suddenly makes sense. The planet has not been forced into a new state. The laws governing it have been edited locally so that the new state requires no resistance. And when astronomers examined the final orientation of Earth's axis, now directed toward the coordinates of Cygnus X1, another possibility emerged. The configuration resembles a pointing system, a planetary beacon aligned toward a fixed cosmic reference. 3IATLAS may not have arrived to destroy Earth. It may have arrived to configure it. If that interpretation is correct, then the shorter day and adjusted axis are not side effects of an attack. They are the final settings of a completed process. Earth has been synchronized, oriented, and cataloged within a system that may have been operating across the galaxy long before human civilization ever looked up at the stars. If you want to follow the next updates as scientists continue analyzing the data and uncovering what 3IATLAS may actually be doing here, make sure to subscribe, turn on notifications, and share this video so you don't miss the next discovery. By this stage, the scientific community had already accepted that Earth's rotation was being altered by an external mechanism. But the deeper analysis revealed that the change in rotational speed was only one part of a much larger system being adjusted in real time. The most puzzling detail was not the acceleration itself, it was the extraordinary level of control being applied to prevent the side effects that should normally follow an event of this scale. Under normal physical conditions, a sudden increase in planetary rotation would release enormous tectonic stress. The crust would experience uneven strain along the boundaries of major lithospheric plates. The Pacific Ring of Fire would likely erupt with massive earthquakes and volcanic activity. The mid-Atlantic ridge would fracture as the seafloor attempted to redistribute the forces acting across the planet's surface. The Himalayan collision zone, where the Indian plate pushes into Eurasia, would register powerful seismic movement. In short, the entire planet should have responded violently to such a dramatic mechanical change. But none of that is happening. Global seismographic networks report activity levels that remain within normal background patterns. The expected chain reaction of tectonic ruptures simply has not appeared. This unexpected stability suggests that whatever field is accelerating the planet is also applying a secondary stabilizing force across major geological boundaries. Instead of allowing the built-up stress to release through earthquakes, the field appears to be compressing the fault systems just enough to keep them below their breaking thresholds. In effect, two operations are occurring simultaneously. One component of the field applies torque, steadily increasing the planet's rotation rate. Another component counteracts the mechanical consequences of that acceleration by distributing pressure along tectonic faults and maintaining structural balance across the lithosphere. The process resembles a carefully controlled engineering system rather than a random cosmic disturbance. The response of Earth's magnetic field provides further evidence that this adjustment is occurring in a coordinated way. The magnetic field is generated by the geodynamo, the motion of liquid iron circulating through the outer core. These currents are strongly influenced by the Coriolis effect, which organizes the moving metal into spiraling patterns that sustain the global magnetic field. When the rotation of the planet increases, the Coriolis force becomes stronger. This encourages more organized convective motion in the core and strengthens the magnetic field. Exactly that pattern has been observed. Within a few hours of the initial rotational acceleration, magnetospheric monitoring satellites detected a noticeable rise in magnetic intensity. The increase measured approximately 12%, a value remarkably close to theoretical predictions for how the geodynamo should respond to faster planetary rotation. While the effect is scientifically consistent, it also introduces a new set of challenges for the technological systems built around Earth's electromagnetic environment. According to Faraday's law of induction, any change in a magnetic field generates electrical potential in nearby conductors. Modern civilization depends heavily on extremely long conductive systems, from transoceanic communication cables to continental power transmission lines. When Earth's magnetic field begins changing rapidly, these structures behave like giant antennas, collecting induced electrical currents. Early measurements already show unusual electrical behavior in several power grids. Long-distance transmission lines are recording phantom currents that exceed the thresholds expected during normal geomagnetic activity. Submarine cables linking continents are accumulating small but measurable voltage differences. Even pipelines extending across thousands of kilometers are beginning to develop electrochemical potentials that engineers normally spend years preventing. These electrical anomalies are not failures of infrastructure, they are a direct physical response to the strengthening and shifting magnetic environment surrounding the planet. As long as the magnetic field continues changing, these induced voltages will persist, and the magnetic field will not stabilize until the rotation stabilizes. Which means the ultimate outcome of this event still depends on a single unresolved variable, the final rotational period that 3IATLAS is attempting to achieve.